So for the last section of this module, we are going to look a little bit more in depth at graphing parabolas and quadratic equations. First thing we want to do, we're going to look at four things. I want to know what the vertex is, which we've done. I want to know what the x-intercepts are, which we've done. That's factoring or square root method, whatever. We want to know what the y-intercept is, which is something you've done. So the new part is the axis of symmetry, and that's just going to be where do we fold this thing so its little arms lay on top of each other. So we're going to do some, we're going to do this one all the way through, and then we'll work backwards so you can see where the axis of symmetry is coming from. So the first thing I want to do is find the vertex. This is in general form, so I'm going to use the format of a negative b over 2a, find that, that's my x-coordinate of my vertex, and then substitute it back into my function to find the y-coordinate of my vertex. So this has an a value of 4, a b value of negative 12, and a c value of negative 3. So that is something that I don't need the c, but I might need it soon. So we're just going to highlight it. So I've got an a of 4 and a b of negative 12. So my b, I need a negative b. So do negative negative 12, which is 12 over 4, or 2 times 4. So that gives me 12 over 8, which gives me 3 halves. Okay? So my x-coordinate of my vertex is 3 halves. Well, now I'm going to put 3 halves back into my function, and that will tell me the corresponding y value of my vertex. So I have 4 times 3 halves squared minus 12 times 3 halves minus 3. So order of operations says do our exponents first. So that gives me 4, and then 3 times 3 and 2 times 2 is 9/4. This one I can multiply straight across the top, straight across the bottom. So 12 times 3 is 36. Over 1 times 2 is 2. And then I'll have a minus 3. So this is 36 over 4. But remember, I can also reduce up front. So I can just kill off the 4's because any number divided by itself is 1. So now I have 9 minus 18 minus 3. So 9 minus 18 is negative 9. Minus 3 is negative 12. So I have a vertex at 3 halves, negative 12. So my vertex is at 3 halves, negative 12. Okay, I also know he's opening in an upwards fashion. So let's look at this for a second. If I plot my vertex at 3 halves, which is 1.5, negative 12, and then I draw it, and I don't know how beautiful this is going to be because it's a sketch, okay? But first of all, notice we're going to get 2 real intercepts. This thing hits the x-axis twice, so we're going to get 2 answers. The next thing I want to notice is that where would I fold it for its arms to lay on top of each other? Well, if I just drop that thing right through the vertex, then I'll actually know where to fold it, because if I fold it here, then that arm will lay on top of that arm. Okay, this arm would lay on top of this arm. So what am I slicing through? I'm slicing through the x-coordinate of my vertex. So my axis of symmetry is simply going to be x equals the x-coordinate of my vertex. Okay, so I have an axis of symmetry at x equals 3 halves. You can't just put 3 halves. You have to put x equals 3 halves. Okay, so what's my x-intercepts? These are something that we know. And actually, let's do y-intercepts real quick, just so I can save some room. My y-intercept is going to be of the form 0, comma, some number. I want to know where this thing hits the y-axis. So that coordinate would look like 0, comma, something. So my x would be 0. Okay, so I am going to evaluate at 0 to find out what number spits out. So 4 times 0 squared minus 12 times 0 gives me negative 3. So my y-intercept is at 0, negative 3. Now let's do the x-intercepts. So for an x-intercept, I need to set this equal to 0. So I've got a 4x squared minus a 12x minus 3 equals 0. So what will my x-intercepts look like? They're going to look like a number, comma, 0. So I'll have a number, comma, 0, which means I want my y value to be 0. So we're going to try and factor first. Multiply your first and last, which gives me a negative 12x squared. Are there two numbers that multiply to negative 12 that add up to negative 12? And there's not. So factoring is not going to work. So that means that this quadratic is prime. It means I can still break it down, but it's going to break down ugly. Okay? So what am I going to do? I'm going to go ahead and use quadratic formula. So I get negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to start plopping in numbers. I need negative b. Well, negative 12 is 12. Plus or minus b squared. So grab b, which is negative 12. And negative 12 times negative 12 is 144. So this gives me 144 minus 4 times a times c, which is minus 3. Negative 3, sorry. All over 2 times a. So I'm just going to do all this stuff underneath the radical. Don't take the square root of 144. We have to simplify first. So this is actually 144. And then I've got a negative 4 times a 4 times a negative 3. So negative 4 times negative 3 is 12. 12 times 4 is 48. So this is going to be 144 plus 48. Okay? Or you can just, on your calculator, 144 minus 4 times negative 3. Make sure you hit the negative, and you get 192. So I now have 12 plus or minus the square root of 192 over 8. So now I want to start breaking down that 192. Okay, so it's a larger number than what we're used to dealing with. As far as we're used to dealing with two digits, maybe a few 3 digits. So I need to see if this can be broken down or not. Okay, so the way that I'm going to break this thing down is, I know it's even. So I just want to see if I can pull out some factors that are perfect squares. Okay, so I'm going to try a few. And this is not the most efficient way, but we're going to do 192. And I'm going to try divided by 4 first. Okay, well, that gives me 48. That's a pretty big number. I bet I can still break it down. So 192 divided by, I just did 2 squared, so let's do 3 squared. So divide it by 9. And I don't get anything pretty. Okay, 192 divided by 16. And I get 12. 12 still has a factor that's a perfect square. Okay, which means I can keep trying bigger perfect squares. So 192 divided by, I just did 4 squared, so let's do 5 squared. Well, that's not going to work. Okay, 192 divided by 6 squared is going to give me 5.33333 repeating. Okay, so let's do 192 divided by 7 squared, which is 49. That doesn't work. 192 divided by 8 squared. There we go. So it's 64 times 3, and 3 is a nice pretty little number. Okay, there are faster ways, and I'll show you those in class. So I've got a 12 plus or minus the square root of 64 times 3, and that's going to be over 8. So I know what the square root of 64 is. It's 8. So 12 plus or minus 8 root 3 over 8. That root 3 is untouchable. Don't try and touch him. But what's the biggest number I can divide out of 4, 8, and 8? I can divide a 4 out of all of those. So I'm going to change pen colors just for tracking purposes. So I'm going to divide out of 4. And that leaves me with a 3 plus 2 root 3 over 4 over 2. Okay, so any number divided by itself is 1. I forgot my minus. So we have 2 solutions. One of them is 3 plus 2 root 3 over 2 at 0. So I could put this in my calculator and get a decimal approximation, but I want to keep it like this. Okay. The other one is going to be 3 minus 2 root 3 over 2. So those, comma 0, comma 0. Okay, so those are the two x-intercepts. So my x-intercept up here would be those two that I just listed down here. So I have completed this one. And now when we try and graph this thing, what we'll end up with is our vertex at 3/2, negative 12. So at 1.5, and then drop it down to negative 12. So I'm going to be off the chart. I can get 0, negative 3 was my y-intercept. Okay. And then I have a vertical, not asymptote, but a vertical axis of reflection that's going to slice through my vertex. And then I would actually plot these points and find out what they are. But I know that that one has got to be like this. Okay. So that is my really, really rough sketch. It's a very rough sketch. Okay. So just for kicks, what's your domain? My domain is all real numbers. What's your range? What's the lowest this thing is going to bottom out at? My range is going to be from negative 12 to positive infinity. All right, so let's look at this one. We've got a negative 2x squared plus a 5x minus 8. So I'm going to make a list of what we need. We need to know the vertex. We need to know the axis of symmetry. We need to know the intercepts. So the x-intercept, there might be 2 of them. There might be 1 or 0. And the y-intercept. Okay? So what is our function? Our function is a negative 2x squared. We already found out he's opening downwards. He's leading off negative. He'll open downwards. So a negative 2x squared plus 5x minus 8. Okay? So he's in general form. I would like to find the vertex first. So my vertex is going to be at negative b over 2a. Find that value and sub back into your function. So negative b is going to be a negative 5 over 2 times a, which is 2 times negative 2. So I get a negative 5 over a negative 4, which is 5/4. So I'm going to put 5/4 back into my function to find out what my y-coordinate of my vertex is. So negative 2 times 5/4 squared plus 5 times 5/4 minus 8. So I'm going to square first. I get a negative 2 times 25/16 plus 25/4. I put 24/4. 25/4. Because remember, you're going over 1. Minus 8. Okay, so I can reduce this way. So a 2 reduces with a 16 by 8. So that gives me a negative 25/8 plus 25/4 minus 8. I need a common denominator here, which is going to be 8. So I'm going to multiply top and bottom by 2, which gives me a negative 25/8 plus 50/8 minus 8. So I get 25/8 again. 50/8 minus 25/8 must be 25/8. So then 25/8 minus 8. I need a common denominator of 8. So I'm going to multiply top and bottom by 8. So I get 25 minus 64. 8ths, which I'm too tired to do in my head. So 25 minus 64 is negative 39/8. So my y-coordinate of my vertex is a negative 39/8. Okay, so let's look at this because it's going to be nifty. Are you ready? If I plot this, okay, my vertex is at 5/4, and then I drop down to negative 39/8. What do we know? We know that it opens downwards. You will not ever intercept the x-axis. So your x-intercepts are complex numbers. You're going to have imaginary solutions for your x-intercepts, okay? And I don't need to know what they are because x-intercepts that are imaginary don't exist. What's my y-intercept? My y-intercept means I'm going to shove in zeros for my x's. So this will go away. This will go away, so I'll end up with a 0, -8 for my y-intercept. So this, if I were to drop it down, this would hit at 0, -8. Okay? What's my axis of symmetry? Well, let's look at my vertex first. My vertex was 5/4, comma, -39/8. Which, how many times does 8 go into 39? It goes in between 4 and 5 times, almost 5 times. So this is almost -5. Okay? So my vertex has an x-coordinate of 5/4. So my axis of symmetry is x equals 5/4. That's where I would draw an imaginary vertical line to fold it across so that the little arms would lay on top of each other. So, again, if I were to graph this, I just graphed it on my paper so you can graph it on yours. Okay, here's 0, -8. I would have 5/4, which is 1.2. So right about here. And I would drop to almost 5. So almost 5 would be right about here. That was almost 4. So somewhere right in the middle of that grid mark is what I'm looking at. So this would drop down like this, and then it would drop down like this, and your axis of symmetry would slice through x at 5/4. Pretty. Okay, we have 2 more examples, and they're a little bit more straightforward. So we've got, write the equation for the graphed quadratic function. We've already done this, we just didn't do a picture. So let's find the vertex first. So my vertex on this one is 2, -3. And then let's just find a pretty point. I don't care where it is. Don't find one that's like floating around in the grid marks because you don't know what that is. So let's find another pretty point. So here's a pretty point. It's 0, 1. It looks like that's a pretty point and that's a pretty point. But I like 0, 1 simply because I saw it first. Okay? So another pretty point is going to be 0, 1. All right? So we are going to, first of all, y equals a times x minus h squared plus k is vertex form of a parabola. I've got my vertex and I've got a point, which means I can find out if this has a coefficient. I already know it's going to lead off positive because it's opening upwards. Okay, so my y value is, this is my xy and this is my hk. So my y is 1 equals a times my x is 0 minus, change your sign. This is a positive 2, so it's going to turn into a 0 minus 2. Okay, squared plus a k of -3. So 1 equals a times -2 squared minus 3. So I'm going to add 3 and get that out of the way. So 4 is -2 times -2 is 4. So a must be 1. Which means I now know the equation. Because it doesn't say what type of equation. So we're just going to do it in vertex form. So my equation on this one is going to be y equals x minus 2 squared minus 3. And if we wanted it in general form, what would we do? X minus 2 squared minus 3 is x minus 2 times x minus 2, which gives me x squared minus 2x minus 2x plus 4, then minus 3. So I get x squared minus 4x plus 1. X squared minus 4x plus 1. Okay, let's look at this one. I know that my vertex is at -1, 2. And I'm going to need an additional point. That's a 2. So another point on it. Let's just go looking. I need a nice pretty point that hits at a nice pretty place. So here is 0, -1. Okay. So my point is going to be 0, -1. So we're going to find out if we have an A value first. I know it's going to lead off negative because it's opening upside down. So I have y equals A times x minus h squared plus k. So here's an xy. My vertex is my hk. So -1 equals A. My x is 0 minus my h is -1 squared plus 2. Okay. So notice what I said because I keep saying this. That gives me 0 plus 1 squared plus 2. Okay, so notice my vertex had an h of -1. It turned it into a plus 1. So that gives me -1 is A plus 2. Okay. And then, so where did my numbers go? 0 plus 1 is 1. 1 squared is 1. I'm just too lazy to write it. Subtract 2 from both sides. My A is -3. Okay, so looking at this, what I have is y equals A times x minus h squared plus k. I just figured out my A is -3. So y equals a -3 x minus -1, which is x plus 1. I'm serious. X plus 1 squared, and then plus 2. So that is my final in vertex form. So I just took my vertex. Instead of -1, it's now x plus 1. And then my 2 is just plus 2. Now let's see what it would look like if I FOILed it out. So this is vertex form. I've got y equals a -3 x plus 1 times x plus 1 plus 2, which gives me -3 times x squared plus x plus 1 plus 2. So I FOILed this part. I carried the 3, the -3. I carried the positive 2, but I FOILed this. So that gives me a -3 x squared plus 2x plus 1. Now I can distribute my -3. So -3 x squared minus 6x minus 3 plus 2. So my final answer in general form is -3 plus 2 is -1. So I let off negative. I knew it was going to open it in a downwards position. So this is your solution in vertex form. This is your solution in general form. And that is it for Mod 6.